difference between them. Permeability, what is say, it's a property of the porous medium that measures the ability of the formation to transmit fluids. It is the measure of the ease with which the rock will permit the passage of the fluids. So permeability, you can define actually the easiness with which oil can flow from this point to this point, from one point to another point. Okay, that's the permeability. Ease with which the fluid can flow from one point to another point. So it's basically, and it depends on what connectivity of the pore space. If there's good effective porosity, it means there will be a good permeability. If there's no effective porosity, it means they will not be well connected. There will be no permeability and so on. Okay. For the rock to be permeable, as I say, it must contain interconnected pores. So pore has to be effective. They has to be interconnected, and that's what. So permeability is defined fluid property of the porous medium, and it is the ability of the formation to transmit fluid from one place to another place. As I said, a good reservoir should have good porosity and a good permeability. And reservoir permeability we usually determine using the Darcys one. And then we have three kinds of permeabilities: absolute permeability, and we have effective permeability, and we have relative permeability. So if I make the whiteboard, okay. Let's say we have this situation. Okay, now as I said, we have three permeabilities: absolute, effective. K is the symbol we represents permeability, and we have relative. And K permeability. Okay. Now, for example, we are oil. Okay. Now this oil is going from this side to this side. Now, as you see that we are talking about in oil, we said we have three phases: oil, gas, water. We have three phases there. Three phases. Now, in this picture, we are just sending the oil. It means it has only one phase. If you look at this one, it has only one phase. So when we talk about only one phase in the rock, and this is a rock, or you can say a reservoir. When we talk about only one phase, it could be oil, or it could be water, or it could be gas, any one phase. We say that it has the absolute permeability. See, all the permeability inside this rock belongs to this oil, because there's no other fluid. There's only one fluid. Either it is oil, gas, so all the permeability means absolutely. Absolute means all complete. So when all the permeability belongs to this oil, that is the absolute permeability. Now I'm saving this picture and proceeding further for the next effective one. Now imagine that, okay, we have oil, okay, but the rock already, as you saw in the previous pictures, it has some water also. So for example, it has some water here. It has some water on the sides. Okay, now you see that in this one, and we have this one. So now this line represents the water, and this phase represents the oil. Okay, so now we have again the reservoir rock, but this time reservoir has not only one kind of phase, it has two phases now. So it already has water inside, a lot of water inside the porous wave, and it has, we are trying to inject the oil from one side and it is coming out on the other side. So now it has two phases. Now, what is the permeability of this oil in the presence of this water? Okay, permeability of the oil in the presence of water. That is the effective permeability. It actually effective permeability about two phase. Okay, permeability of a certain one in the presence of the overall the permeability inside it, which is, that's the permeability of effective one. So it means it has two phases. Now, what is the permeability of oil in the presence of this water? This is called the effective one. Okay. Now we have the third permeability, which is the relative. Got the idea about this one, absolute and effective? Any question? Any question? No question. Okay. Now I talk about the third one, relative permeability. Now I will give you another example. Now, for example, we have two students. Let me choose. Let's say we have Mr. Let's say we have Mr. Umar. Okay. And then we have another student, Mr. Ribas. Let's say we have two students here, Mr. Umar and Mr. Ribas. Okay. Now they are in a marathon. They both are running together in one direction and on the same road. So the speed of one in the presence of other, okay, that is the relative permeability. So we compare the speed of both of them, how fast they can go from one place to another place in the presence of the other. So if we look at the same concept here, for example, now we have oil and we have another phase here, which is the gas. Okay. And this gas is now we are injecting also at the same time. So now we are injecting oil and gas both in the same rock at the same time. How fast oil can go in the presence of gas, or how fast gas can go in the presence of oil? This is the relative permeability. Means the relative means we are comparing them. Now, a very, very important concept that even sometimes the professors, they don't know. Okay. The relative permeability, let me write it. I'm on it. Relative permeability is not the property of the rock. It is the property of fluid. Even many professors, they don't know, and from good universities. This we need to find out. And effective permeability or absolute K is the property of. Why it is not the property of the fluid, property of it? Why relative permeability is not the property of rock? It is because we are comparing two different running of two different injecting of two different phases. We are not comparing what is going on inside. We are comparing the permeability of oil in the presence of the gas, or permeability of gas in the presence of oil. We are not comparing what is going on in the rock inside. But when I talked about the effective permeability before, we said that there's a one phase already inside the rock, and how much the other for another phase is coming and crossing. So that's the difference between absolute, relative, and effective. Now, if you want to know further about them, there are lots of animations on the YouTube which you can find out, and we can talk about it in much details about the permeability of them. Any question from it?
Sir, one question.
Yeah.
Does the permeability of a reservoir change over time, or it stays constant?
Permeability does not change actually. Effective permeability does not change. Relative permeability definitely changes. Yes. Okay, because the relative permeability, very, very good question you raised. Relative permeability depends on the saturation of the oil. For example, if you have a lot of oil, okay, its permeability will be higher because It will take a lot of space, easily it can go. This is one phase. Or when the oil declines, for example, you produce for 10 years, then this oil probably does not have that much good relative permeability and it may not go up. Okay. But on the other side, the effective and absolute permeability, they do not change. Only relative permeability change. It is depending upon the saturation. And it's a very nice question. It has a book of Tariq Ahmed. I uploaded already. It has a complete chapter on this one. Relative permeability versus saturation. It has a complete book chapter that you can study about the relationship between the saturation versus the relative permeability. Because this is the pure reservoir engineering subject. If you studied reservoir engineering, you might have talked. Anyone taken reservoir engineering so far? No one? Okay. So this is a pure reservoir engineering subject. So as your question says, do the permeability change over time? Relative permeability, yes, because it is depending on the saturation, and saturation declines as we produce oil. Do the absolute permeability change? No. And sometimes yes, because of the earthquakes or because of the stresses, overburden pressure and so on. But usually we don't consider them as, changing one. But relative permeability, yes, it is changing all the time. And there are some more concepts that I will clear, then you will understand how rock. But it's a complete science, and you can do your master's and PhD on this topic, what the question you raised. But it's a very good question. I really appreciate it. May I have your name? Sorry.
Keji.
Okay. I could get back to my lecture. So as I said, we have three kinds: absolute. So now in definition, written words, how they define it. When two or more fluids are present, the permeability of the rock flowing is called the effective permeability. Okay, symbol is like this: KO, KG, and KW. And absolute, as I say, when all the rock has only one fluid and all the permeability belongs to just one phase, that fluid is called the absolute one. The relative permeability is, you see here, oil versus the effective one. Okay, relative permeability is the ratio of absolute to effective. This is how we define. But the explanation, as I said, when two students are running together, speed of one. Well, the permeability basically actually, let me correct this equation first, and then I will be back to you on this. This one actually is this one. Now, how to find this permeability? Well, for that we have the formula here, and permeability, Darcy's law, which helps us to identify the permeability. Well, remember that the all reservoir engineering basically is counting on this Darcy's law. Okay, permeability concept basically comes in Darcy's law. There is experiment on the YouTube. You can find Darcy's law. You can easily find out there. So he has equation, and this K here represents the permeability here. Depends on the area of the reservoir. It depends on the differential pressure. Differential pressure means what is the pressure at first injection point, what is the pressure at the discharge point. Also viscosity of the fluid to matter and length of the matter. So there will be, Darcy's actually basically give us an equation which connects which says that flow rate is depending on the permeability, area, differential pressure, viscosity, and the length of the fluid. That's the one Darcy's one is talk about. And permeability, how we find out permeability, there are ways for finding one. We can find through two main channels. One is through the well test. We have pressure buildup test that we will do in the engineering laboratory course. We will do some, and we have some softwares coming for that to find out this, to do this, finding this permeability using the pressure buildup test and so on. So by next week, you will be able to have those softwares in the labs of the AUIS. Now permeability, what is a good permeability? If permeability is between above 200 or to 250 millidarcy, then we say it's a very good permeability. And in US shale reservoir, basically permeability is less than 1. So it actually cannot even flow because the pores are not really connected. So it's very poor there actually. So that's why. But the good one, then there are fair, moderate, good, and so I'm just talking about the bad and good. The very good one is above 250 millidarcy, poor one is the less than 1. And we use the unit millidarcy to find out the permeability and so on. Okay. Permeability definitely depends on some factors, shape and size, and the fluid density also, and saturation also, overburden pressure also, and fracturing and dissolution. All these affect the permeability. Okay. Now, permeability also is in 3 direction, X direction, Y direction, and Z direction, and so on. Then the third one is the fluid saturation. As I said in the, let me clear this one. Okay. As I said, we have 3 phases: oil, gas,